Solving homework will not only earn you credit, but also help you prepare for online quizzes. More importantly, solving engineering problems correctly will make you understand the concept thoroughly and make you a better engineer. So in this short video, I'm going to go over how do you find the group name, join the homework group so that your work is graded. And then I'll show you how you solve a problem manually and verify using test calcs. And then finally enter your answers and so that you can see your record grow as far as homework is concerned. So let us start by going to thermofluids.net. And in case you do not have an account, you can create an account by clicking the Create an Account button, filling out the form. But in this case, I'm going to log in as a generic student. And go to the problem sections. That's where all the homeworks are listed. I mean, these are the same problems that at the back of your book, in the end of every chapter that appears. So if you go to chapter 2, you can see all the problems. You can browse down or up, or you can go to a specific section. Suppose you go to section 3 versus section 4, etc. So what are the assigned problems? For that, you got to go to class TA and log in there. So again, I'm assuming you already have an account there, student at stsu.edu. Okay, and since we have already joined the class, you will see this class icon. Open that. In the shared files, you will find this homework document. Open it and you will see general instructions at the top. If you scroll down, you will find the assigned homework. Let's say we are trying to solve one of these assignments, assignment number 1. Let's try to solve problem 258. So what does that mean? That means you go to thermofluids.net, go to problem section, go to chapter 2, go to section 5, and find problem 258, this is our problem at hand. Okay, so this is the problem we want to solve, which is a very simple problem. So let's see if we can solve it almost but just by reading the problem and without using a lot of writing. Here's a gas turbine and engine with a thermal efficiency of 21%, and the output is 8 megawatt. What does the output means? That's the work out. Every second, 8 million joules of work, shaft work, is produced by this gas turbine. Determine the fuel consumption rate in kg per minute if the heating value of the fuel is given. Now we know what is heating value. Means if you burn 1 kg of the fuel, it releases 50 million joules of heat. So the question is, how much fuel do we need to produce 8 megawatt of power? So if you take 8 megawatt of power, divide by 0.21, of course we need more heat than the power produced by the engine, divide by 0.21, so we get 38.09. You can just calculate that. 8 divided by 0.21 is 38.09. So the fuel consumption rate in kg per minute would be what? Let's go back if you want to write that down. So we have efficiency is 21%, 0.21 is W dot net by Q dot in. So that gives us Q dot in to be 8 million joule by 0.021 equals 38, about 38 million joule. sorry, 38 megawatt. All right, 8 megawatt divided by 0.21. So the fuel consumption rate, therefore, is that if you think about it, if you burn 1 kg, let's go back to the problem, 50 million joules is released for 1 kg of, 1 kg of fuel. So therefore, if you want to find how much fuel is getting consumed, all you need to do is to take this 38 divided by 50, so that's million joule per second, million joules per kg. So we got kg per second of fuel consumption and multiply that by 60. So we get 45.6 kg per minute. Anyway, my goal here is not to show you how to solve the problem, but rather how do you get credit for a problem you know how to solve. So suppose you figured out the fuel consumption rate is 45.6 kg per minute. So now how do you get credit for solving that problem? Okay, go back to the problem, and if you click on 258, see the problem number you click on and it brings up this form, and you can enter your answer right here. So we found part A to be 45.6. So let's suppose we put it to be 0, and you say grade my answer. Obviously it's wrong. And if we put in 45.6, voila, this part is correct. But remember, we just solved the problem manually, and what is advisable is always to verify your answer with a test calc if possible. So for that, we go to thermofluids.net again, and we try to launch an appropriate test calc. We go to the test calcs page and recognize that a heat engine is a closed steady system. We click there, and then we try to launch the test calc. Well, we click the run button. In your computer, in Firefox, this sometimes you may find that Java is disabled. In that case, you have to select allow and remember to run the Java applet. Okay, so notice that in the I/O panel here, which act like a calculator. So remember the calculations that we made. For instance, I said suppose we divided 8 megawatt by 0.21, the efficiency, to figure out the heat transfer to be 38 million megawatts. So notice we can use this as an I/O panel, as a calculator. Anyway, to solve the problem using the test calc, let's see what is the second part. If the maximum temperature achieved during the combustion of diesel is 1700 Kelvin, determine the maximum thermal efficiency. Atmospheric temperature is 300 Kelvin. Of course, the maximum thermal efficiency is the Carnot efficiency. So we don't have to understand how a gas turbine works at all. We go there and we say high temperature is 1700 Kelvin, and the cold temperature or the low temperature is TC is, this is 1700 Kelvin, and it is 300 Kelvin. If you do a calculate, it finds the thermal efficiency of the Carnot efficiency to be 82.35%. Well, no big deal. The answer is what? 1 minus TC over TH. So it is such a simple problem, we could solve it in one second. But it's good to verify here. Again, we could use the calculator here. 1 minus 300 divided by 1700 is 0.8235. This is exactly what we got, 82.35%. So we go back. We go back to the problem panel, and we enter our answer. This is in percent, so it's 82.35. Always there will be some tolerance, so you don't have to really always enter very precise answer. Grade my answer. Yes, both of them are correct, solved correctly. And you can see that you can click the progress report, and it will tell you how many problems you have solved, etc. So great. We have solved the problem, and notice the background of this problem became green, and the system will remember. So next time you log into thermofluids.net, for your entire lifetime, if you come back here for that matter, you'll know that you solved that problem one day. So this is the kind of confidence that you will have for the rest of your life. So now let's go and see how to join the group, which I promised that we'll do in the beginning, but I forgot. You'll notice that connecting with the group comes in the bottom, and we already have subscribed to one group, so let's subscribe to the current group. So you go to find out the group name. The group name is listed in this instruction in your classTA.net shared files. So if you go to the homework file, again, I'm talking about if you go to the class ME351 ISU16, go to the shared files and homework. That's where all the assignments are, and the instructions are in the top, and this is the group name. So what I'm doing, I'm copying the entire group name from here, Control C, it's in red, because typing it in will always, there's a good chance that we can make a mistake. So you click here in this yellow field and we paste that group name and we click join the group, and it says we have to say okay here, only then you have joined the group. So notice that you have joined the group and the group name appears here. Later you can always go and select the group, and you can ask that generate my progress report, and if you click the go button, it will show you how many problems you have solved, how many points you have earned, etc. So I guess it's pretty straightforward. All you have to remember, go to classta.net, find that homework file. All the homework is listed at the bottom, and even this particular video I'm making right now will be embedded here. And then you solve the problem on piece of paper, and make sure you keep that as record, because in the future, if I want to see your handwritten solutions, I have the right to ask you, and you have to scan those solutions and send it to me. So I want to make sure you have solved the homework problems manually, and if possible, verify them using test calc so that you are 100% sure, and that's how you get full credit. If there is any question, go to the discussion blog for this class, and you will find a homework section, and you can post a comment there. See you online.